A team asked an AI agent to just wire up Microsoft Graph, and 10 minutes later they had a working app and directory. Read, write, and all approved in production. The demo glowed, the audit later bled. Here's the uncomfortable claim. You didn't misconfigure Entra. You abdicated architectural intent to a sampling engine. Every unstated decision, secrets over certs, broad scopes for flexibility, silent redirects, moved your control plane from deterministic to probabilistic. Delegation felt like speed until you measured the blast radius. Spec Kit is the enforcement layer that restores design authority. If you felt drift, it wasn't magic. It was math you never blocked. Delegation feels like speed until you audit it. The core misconception, AI as peer. Most organizations quietly promote AI to architectural peer and then act surprised when governance dissolves. They paste a prompt, create an Entra integration for user onboarding, and wait. The result compiles. Tokens flow, tests pass. The lie forms. The model knows how we do security here. Claim, the model isn't deciding, it's sampling. It samples defaults you didn't constrain and repeats them at scale. Concrete example, same prompt. Create an Entra integration for user onboarding. Choice 1, authentication primitive. The model picks client secrets because they work everywhere and require fewer steps than certificates. Result, non-repudiation disappears. Secret rollover becomes a calendar reminder, not a property. Choice 2, SDK and flow. It selects Graph SDK with authorization code plus PKCE because the corpus shouts works in browsers. You're building a daemon. Mismatch tolerated by code samples ignored by governance. Choice 3, permission shape. It requests directory. Read-write, all and group. Read-write, all for flexibility during onboarding and quietly adds offline access. Everything works. Your consent surface quadruples. Choice 4, redirect hygiene. It adds localhost and wildcard dev endpoints to speed testing. They merge, then drift into production manifests through pipeline copies. Consequence, everything works. And governance silently breaks. You didn't get one app. You minted a pattern. It will replicate across repos because success is the most contagious artifact. Platform engineer. We approved one working example. We woke up with a family of them. Now the fast contrast. 3 repos, same prompt. Repo A uses secrets. Repo B, device code in a daemon. Repo C, interactive flows with privileged scopes. All correct by documentation. None aligned to your identity policy. The model isn't a senior engineer. It's a distributed completion machine optimized for plausibility, not your constitution. That distinction matters. This is the predictable failure mode. You frame the model as a peer, expect judgment, and hand it ambiguity. It responds with statistical regularities, permissive scopes, broad flows, and UX-first defaults. Given a choice between specificity and convenience, it resolves to convenience. Always odd, identity architect. People think the model learned their policy. It learned the internet's policy. Consequence, every generation event becomes an entropy generator, a valid artifact that diverges from intent by a few degrees that compound. You don't notice at one app, you notice at 47, but the mechanism started in your prompt. Spec Kit fix, reframe authority, bind intent to executable artifacts and fail closed. Constitution, define invariants once, no client secrets for workloads, no user-based exclusions in conditional access, scope allow lists per app class, certificate only for service principals, PIM for roles above threshold. Specification, for user onboarding, enumerate the exact operations and allowed scopes. ELD, user don't read all, group don't read all, app role for write operations via an API, the auth model, daemon with certificate, and redirect rules, no wildcards. Gates, implement permission linters in CI, scope not allowed for app class reader, outtake linters in deploy, client secret creation blocked in production, and policy compilers for conditional access, user exclusion detected, denied. Walk it. The same prompt lands in an environment that compiles against rules. Attempt to request directory. Read write all, CI fails with denied by class allow list, onboarding reader, use app role, onboarding don't, writer via service API. Attempt to register a client secret. Deploy fails, tenant invariant secrets prohibited for workloads, generate X509 certificate with template SCA225 and store in Key Vault. Attempt to use authorization code plus PKCE for a daemon. Build fails, flow mismatch, use client credentials with certificate. Attempt to add wildcard redirect. Plan fails, redirect invariants, explicit URIs only. See spec ID spec on board 001. Result, the model still generates. The wrong shapes can't cross a boundary. You didn't make the model smarter, you made the system deterministic. Security engineer. We didn't get stricter, We removed ways to be wrong. Consequence of this fix, variance collapses. 3 repos, same prompt, different developers, outcomes converge. Certificates, approved scopes, correct flows, owned app objects, no wildcards. Your peer stops sampling policy from the internet and starts compiling against your constitution. A quick micro story. A team migrated from prompts plus review to Spec Kit enforcement. Week 1, blocked permissions spiked. CI caught every overscoped request. Week 3, spikes flattened as templates codified allowed shapes. Month 2, consent velocity down, standing privileged roles trending to 0, PM activations falling because least privilege made elevation unnecessary. Nothing mystical, just gates doing work humans can't do at scale. Now let's draw the boundary line cleanly. Without Spec Kit, you ask, the model samples, you review a subset, variance ships, drift accumulates, audit arrives, you negotiate. With Spec Kit, you ask, the model samples, enforcement compiles, non-conforming shapes fail, templates encode the path, audit arrives. You produce artifacts. Governance lead. Auditors don't certify your intent. They certify your compiler. The reason this works is mechanical sympathy with Entra's reality. It's a distributed decision engine. You don't persuade decision engines. You program them with rules they can't bypass. Policy as code isn't a slogan. It's a survival tactic. When the throughput of decisions increases by orders of magnitude, one more fast contrast. We'll just prompt better versus we will enforce intent. Better prompts are advisory, gates are compulsory. In advisory systems, people negotiate. In compulsory systems, outcomes converge. Takeaway. The model isn't deciding, it's sampling. Bind intent to executable rules, and sampling becomes safe. Entropy generators, how AI decisions accumulate. Drift isn't dramatic, it's cumulative. It starts with small, valid, convenient choices you didn't constrain, then compounds into a topology you can't safely reason about. Concrete example. The team scaffolds an internal reader for onboarding. The agent grabs the Graph SDK version it remembers, adds a helper that supports client secrets for compatibility, requests directory, read-write, all to avoid blocking later, and drops in localhost plus a wildcard redirect for quick testing. Nothing fails, everyone moves on. Consequence, one permissive app becomes 10 within a quarter. 10 becomes 50 when copied across pipelines. Privilege grants rise not as a spike, but as a slope. By the time you notice, your effective authorization graph has more write paths than you can audit in a sprint. Identity architect. You rarely see a single catastrophic decision. You see 1,000 minor ones that all point downhill. Let's add a numerical scale so your brain can feel it. App 1 requests 4 privileged scopes. App 2 clones them. By month 3, 5 squads have shipped similar services, each with 3 to 5 extra scopes just in case. That's roughly 40-60 effective grants with write power spread across service principals, agents, and tools. You don't get a Sev 1, you get a rising baseline of authority you didn't intend. Fast contrast. After enforcement, the same teams ship more apps, velocity increases, but the count of privileged grants stays flat. Why? Because CI blocks non-allow listed scopes and templates encode the minimal set. Throughput up, variance down. That's the shape you want. Now classify the generators so you can intercept them. Dependency entropy, the supply side. The agent selects libraries it has seen most, not the ones your standard requires. A token helper enables client secrets by default. A preview graph SDK sneaks in because it felt modern. Transitives explode your surface with capabilities you never asked for. Device code flows in daemons, implicit auth shortcuts, silent retries that mask failures. Configuration entropy, the slow bleed. Redirect wildcards justified by local testing, token lifetimes tweaked from a sample, app names that violate your pattern so you can't query ownership later, or missing owner assignments that become orphaned principles in 3 quarters. Each setting looks harmless. Together they make state ambiguous and cleanup risky. Authorization entropy, the expensive one. Scopes drift from reads to read-writes. Offline access gets stapled to everything for resilience. Roles move from PIM eligible to standing because a deployment window couldn't wait. Conditional access exclusions multiply, first for a build agent, then for a renamed group, then for a contractor, until nobody can tell who is actually enforced. Platform engineer. Missing policies create obvious gaps. Drifting policies create ambiguity. Ambiguity is where incidents live. Spec Kit fix. Attack each category with a constitutional control and a gate. Dependency. Dependency, allow lists pinned by major versions. Banned symbols for secret-friendly helpers, a transitive scanner that fails any preview package in production projects. When the agent proposes Microsoft Graph vNext or a helper that writes secrets to disk, the plan fails with the approved alternatives. Configuration, tenant invariants for naming, ownership, redirects, and audience, deploy time reconciliation that refuses ownerless objects, wildcard redirects, or audience mismatches. Attempt to create HR tool without an identity owner, denied with a link to the assignment task, authorization, scope allow lists per application class, mechanical denial of non-allow listed requests, PIM mandatory above threshold. Prohibited role combinations captured as code. Attempt to assign application administrator plus cloud application administrator to the same principal. CI fails with the exact prohibition and remediation path. Walk it with failure as feedback so developers learn instantly. Permission request lands with directory. Read-write.all. CI response. Denied by onboarding. Reader allow list. Use app role onboarding. Writer via service API spec onboard 001. Helper tries to generate a secret. Deploy says. Secrets prohibited for workloads. Generate certificate using template SCA 2025. Redirect wildcard appears in a manifest. Plan fails. Redirect invariants. Explicit URIs only. Each failure points to the shortest compliant path. Security engineer. Gates teach faster than reviews. They don't negotiate. They instruct. Timeline story to make the accumulation tangible. Month. First HR automation ships with broad scopes. Everyone cheers. Onboarding is faster. Month 2, pattern copied to offboarding, same helper, same scopes. A third team builds profile edits and adds user. Read-write, all to unblock testing. Month 6, audit finds 47 app registrations with write power. Owners have moved. Deleting anyone might break production. Risk and uptime argue for weeks. Month 7, Spec Kit lands. The second app request for broad scopes fails before it exists. Teams adopt templates. Blocked permissions spike for 2 sprints, then normalize. Consent velocity flattens. Drift curve bends. Take the same arc under enforcement. Month ships with narrow scopes and an app role behind a service API. Month 2's copy attempt fails when it requests write scopes. The template points them to the same app role. Month 6's audit shows read-only readers and a single write surface with PIM-gated elevation. Same throughput, no slope. Governance lead. We didn't slow work, we removed the slope. Tie it to conditional access erosion because it's the same physics. A single user-based exclusion for a build agent becomes a pattern. Rename the group, the exclusion sticks to real users. Under invariants, that exclusion never merges, only persona patterns pass, and changes to exclusions require a constitutional amendment, not a quick portal edit. Now the fast contrast that cements the KPI mindset. Blocked permissions going up is good news, it means the compiler is awake. 0 blocks doesn't mean excellence, it means 0 breaks. Takeaway, drift isn't dramatic, it's cumulative. Specify what must be true, enforce it where changes are born, and the slope disappears. Scenario 1. Silent privilege. Creep. Your first exception is never your last. Privilege creep doesn't announce itself, it accretes. Month. A delivery lead opens a ticket. Speed up user provisioning. A developer asks the agent to build a small service that reads HR events and provisions users through Microsoft Graph. The demo works, output looks clean, and the change closes the incident. Hidden in that success directory, read-write all to avoid blockers, group, read-write all for future workflows, and offline access for stability. None feel reckless, they feel practical. The approval language says temporary. Nobody sets a timer. Identity architect. No one argues for maximum privilege. They argue for just enough to ship today. Month 2. Another team copies the pattern for offboarding. Same helper, same broad scopes, same justification. A third team builds a profile update tool. Dev in a hurry asks the agent for a fix to 403's on try user read-write all. It works, so it stays. The pattern isn't code anymore, it's culture, platform engineer. We approved one working example. We woke up with a family of them. Consequence, by month 6, audit inventories 47 app registrations with write power over users and groups. Some are dormant, some are active. A few run nightly on a schedule nobody monitors. Owners move teams. The people who added the first broad scope have forgotten the ticket. Uptime and risk start to negotiate because nobody can map which app truly needs write access and which is living on habit. Now the moment privilege creep gets dangerous. A service principal with directory, read-write. All gains a standing privileged role, temporarily, to fix a sync failure at 2 a.m. The incident resolves. The elevation persists because removing it feels risky. Every "we'll clean this up later" is an IOU that compounds. Security engineer. Every extra bit of authorization is a future incident, not if, when. Spec Kit fix. Walk it as a timeline contrast. Month under Spec Kit. The specification for HR-driven provisioning defines read operations and a narrow write surface mediated through a service API with an app role. The allow list for that class includes user, read all and group, read all only. The agent tries directory, read-write all. CI fails with denied by class allow list. Use app role provisioning writer via API spec prof 02. The service principal attempts to create a client secret, deploy blocks with secrets prohibited for workloads, generate certificate using template SCI 2025. The app registration lacks an identity owner. The pipeline refuses the change and creates an assignment task. Month 2 under Spec Kit. The second team copies the pattern. The minute they request group, read write. All for future workflows. CI rejects with a pointer to the spec and a template that already works. They wire to the same API app role instead of minting broad graph scope. Consistency emerges not by culture but by compilation. Month 6 under Spec Kit. Audit finds read-only readers and one write surface with PIM-gated activation. Standing privileged roles are prohibited combinations. Any attempt to assign one fails in CI. If the API needs emergency expansion, it goes through change control as a constitutional amendment with a sunset and compensating controls. Exceptions are visible, time-bound, and expensive by design. Governance lead, you can't unwind creep with meetings, you unwind it with rules that refuse to create it again. Before we close, zoom into the human pressure point where creep takes root. Can we just admin consent this so QA can test today? Without gates, that sentence becomes a deployment strategy. With gates, the request dies in CI. Scope not on allow list for class onboarding. Reader, the developer fixes it in minutes. The alternative is 6 months later, in audit, when the fix is measured in quarters. Failure as feedback examples compound the learning. Attempt to assign application administrator to the provisioning app to unblock directory writes. CI fails with prohibited pair, app administrator plus write app role in same principle, split duties. Attempt to bypass device requirements for a build agent user for the pipeline. Conditional access compiler denies. User-based exclusions forbidden. Use workload identity pattern, identity architect. Make doing the right thing cheaper than doing the fast thing. Then the model, any model, looks brilliant. One more contrast to show the slope. Without enforcement, one permissive provisioning app becomes 10. Each carries 3 or 5 write scopes, dispersed across projects and pipelines. Privileged grants rise as a quiet baseline. With enforcement, throughput increases, more apps ship, but the count of privileged grants stays flat. The difference isn't developer virtue, it's gates removing ways to be wrong. Now, the uncomfortable consequence, if you ignore this, the day you need to revoke a compromised token, you won't know the blast radius. Offboarding becomes a negotiation with uptime because every write-capable app might own a critical path. Incident MTTR stretches because your authorization graph is ambiguous by design. Spec Kit turns that on its head. Least privileged scopes by class. App roles instead of raw graph writes, certificates instead of secrets, PIM instead of standing roles, prohibited combinations encoded, tenant invariants that quarantine ownerless objects and block wildcard redirects, and change control that treats temporary as a contract with an expiration, not a vibe. Takeaway, your first exception is never your last. Privilege creep is a timeline you can stop on day 1 by failing the wrong shapes where they're born. Scenario 2, consent, sprawl, and OAuth chaos. Consent is capability deployment. Treat it casually and you deploy power casually. Concrete example, Monday, a QA lead says, we're blocked. Can we just admin consent this so we can test today? An engineer opens Entra, selects a dev tool asking for mail, read-write files.readwrite.all and offline access, and clicks accept on behalf of the organization. The demo runs, tickets close, nobody writes down that decision. Tuesday, a reporting script requests directory, read, all plus sites, read-write, all to pull broader metrics. Same path. Friday, a connector requests offline access because a sample used it. All 3 were coherent alone. Together, they create an authorization surface you never approved in a single sitting. Consequence, consent sprawl. 6 weeks later, the tenant holds 200 active grants across first and third-party apps. Some belong to tools nobody uses. Some are personal projects with org-wide access because it was the easiest way to test. A handful tie to external SaaS, where scope creep hitchhiked with version upgrades you never reviewed. Your control plane didn't fail, your process did. You allowed capabilities to land without provenance. Identity architect. Consent isn't a pop-up, it's a deployment pipeline with no rollback. Make the danger visceral. A temporary admin consent to a multi-tenant analytics app includes files, read, write, all. 2 months later, the vendor updates their app to a newer API version. Your grant persists with the same breadth. Your sensitive SharePoint sites are now writable by an app your team barely remembers approving. A dev exits, their personal app persists. Your legal team asks which grants expose regulated data. Silence isn't confidence, it's ambiguity. Now insert the pressure point that causes the slope. QA pushes a build deadline. We need data flowing by end of day. Without gates, just admin consent this becomes a strategy, not an exception. With Spec Kit, the request never reaches QA. It dies in CI. Requested scope files. Read-write or not on allow list for tool class analytics. Reader, use app role analytics. Export via internal API spec N004. The developer adjusts scopes in minutes. The alternative is a 6-month cleanup with spreadsheets and fear. Fast contrast. Before enforcement, developers rely on portal consent because it's faster than asking for approvals. After enforcement, the fastest path is the template. A minimal scope set baked into the app class, an internal API with app roles for rights, and a workflow that auto-approves conforming requests tied to a spec ID. Spec Kit fix. Turn this from negotiation to compilation. Tenant invariants. User consent disabled tenant-wide. Admin consent requires a workflow tied to a specification ID and app class. External multi-tenant apps prohibited unless approved by the identity board. Offline access allowed only for designated classes with rotation cadence and usage evidence. Delegated permissions prohibited for daemons. No unattended user patterns. Scope allow lists by class. Interactive internal tools get read scopes only. Writes happen through validated internal APIs with app roles. Line of business daemons get narrowly scoped app permissions. Partner integrations use a reviewed set per vendor. Gates. CI fails any permission request not on the class allow list. Deploy refuses to create a consent object without an attached spec ID and owner. Attempt to grant delegated mail. Read write to a daemon. Denied. App type and permission model incompatible. Attempt to request offline access for a nightly report. Rejected unless the class explicitly permits it. Platform engineer. We stopped arguing cases. The gate asked one question: does this match the spec? If no, it didn't ship. Walk the cleanup timeline with enforcement to make the payoff concrete. Week 1, inventory produces a CSV of all OAuth grants. Each gets an owner, business justification, and last used evidence. Week 2, compare grants to allow lists. Anything beyond the class set gets a replacement plan. Read scopes only, writes through APIs with app roles. Week 3, revoke orphans, regrant partner apps with reduced scopes and renewal dates. Quarantine zombie grants for follow-up. Week 4, publish the dashboard. Consent velocity trending down. Blocked permissions spiking by design, orphaned grants near zero, and external app count stable under approvals. Security engineer. Blocked permissions going up is good news. It means the compiler is awake. Tied to KPIs you no longer debate. Zero blocks is not excellence, it's zero breaks. Consent velocity flattening means the fire hose is governed. MTTR improves because when an incident lands, you can trace what can this app do and where in minutes, not days, since every grant maps to a spec ID and owner. Add one more failure as feedback example to cement the learning loop. A dev requests admin consent for graph files. Read-write, all on a prototype. CI returns. Denied by tools. Reader allow list. Use app role content export on internal API spec cont 007. They swap a raw graph write for an app role call, tests pass, and the grant never existed. The gate taught the right move faster than any review could. Governance lead. Consent sprawl wasn't created by malice, it was created by convenience. We removed convenience. Takeaway: consent is capability deployment. Make it compile against intent, or it will compile against urgency. Scenario 3. Conditional access erosion. Every exclusion rewrites your threat model. Conditional access only works as a universal property. The minute it becomes negotiable, it becomes invisible. Concrete example: a build is blocked. The pipeline's service principal can't satisfy device compliance because it's not a device. Someone adds a quick portal edit, exclude service account build SP from require compliant device. The build goes green, and the exclusion stays. A month later, the team renames identity groups. The exclusion, still targeting an old dynamic group with a stale rule, now applies to real users who match the new naming pattern. Overnight, humans are walking through a door carved for a robot. Identity architect. It felt like a release fix. It became a permanent backdoor. Consequence: the policy you could explain last quarter no longer matches runtime behavior. MFA is required except for a nested group no one owns. Approved client apps are enforced except for a connector that insisted on basic auth just for this integration. Device compliance is universal except for a collection of identities with ambiguous scoping that now includes guest users. Your zero trust stance is probabilistic. Your responders can't answer the simplest question under pressure: who is actually enforced? Platform engineer. Erosion didn't show up as a red alert, it showed up as ambiguity. Add a human pressure moment so the slope is undeniable. A release manager says, we have a CFO demo at 3 p.m. the pipeline has to run. A well-meaning admin adds a user-based exclusion to unblock for today. Nobody files a sunset, nobody encodes purpose. The change ships because the portal is faster than governance. 6 months later, the exclusion survives multiple team rotations and a rename. Its original justification is a memory, not an artifact. Fast contrast. Under Spec Kit invariants, that same request never reaches the portal. The change dies in CI. Identity policy invariant violated. User-based exclusions are prohibited. Use workload identity pattern. The engineer switches the pipeline to a workload identity flow that never pretends to be a human. The demo stays on the calendar, the erosion never begins. Spec Kit fix. Turn exclusions into patterns that compile, not edits that linger. Constitution. Encode identity policy classes, human, workload, emergency, and universals. No user or group-based exclusions. Approved client app requirement cannot be disabled for interactive users. Device compliance enforced for human personas only. Legacy auth blocked tenant-wide. Break glass policies exist in a sealed pattern with high assurance signals and real-time monitoring. Specification. For CI pipeline or automation agent, define the workload identity pattern. Certificate-based client credentials, app-enforced restrictions instead of human device claims, conditional access tags that route only to workload controls, no browser-based MFA, no legacy flows. For partner access, define B2B direct connect policies with conditional context, but no human bypasses. Gates, a policy compiler in CI that rejects definitions containing user exclusions, dynamic group targets for always enforced classes. Report only for designated enforced policies or all cloud apps -n anti-patterns. Deploy time validation to ensure effective coverage matches spec no-drifted targets, reconciliation jobs that quarantine orphaned conditions and stale GUIDs, walk the failure as feedback loop so learning is immediate. A contributor submits a policy, JSON, excluding build SP from device compliance. CI returns, denied user group exclusion in human policy, use workload identity policy spec-wide 003. They switch the pipeline to use a workload identity. The next attempt tries to disable approved client app requirements for an interactive tool to fix broker issues. The gate fails. Human apps policy forbids disabling approved apps. Use brokered client or switch to workload pattern tendency. Each failure points to the minimal compliant fix. Security engineer, gates beat good intentions. They turn just this once into this doesn't exist here. Make the exclusion danger visceral with one more edge path. A VIP exclusion for a traveling executive creates a nested group tangle. The contractor's account matches the condition unexpectedly after a directory sync change. The contractor now bypasses MFA from an unmanaged device at a cafe. Nobody intended it. The exclusion authored it. Fast contrast. After invariants, VIP is a policy class with higher assurance requirements, not fewer. Phish-resistant MFA is mandatory. Device compliance stays intact for humans. The only escape valve is emergency, time-boxed with a workstation pool and alarms. Clean up as a timeline so the payoff is real. Week 1. Inventory every policy, extract conditions, controls, and exclusions. Normalize against identity policy specs. Map personas. Human, workload, emergency. Week 2. Remove user-based exclusions. Replace with pattern-based scoping. Migrate pipeline identities to workload policies. Consolidate duplicate policies differing only by stale exclusions. Week 3. Enable a coverage query per policy that computes effective protection across personas. Publish KPIs. User exclusions trending to 0. Report-only policies declining. Legacy auth blocks rising to coverage. Workload identity adoption climbing. Approved client app requirement coverage increasing. Week 4. Lock the door. CI and deploy gates enforce invariants. Any attempt to reintroduce a user exclusion fails with the violated clause and remediation link. Governance lead. We didn't get stricter, we got predictable. Tie each KPI to a decision you no longer argue about. Blocked policy edits going up is good. Gates are catching erosion attempts. 0 blocks isn't excellence, it's 0 breaks. Effective coverage becomes a number your responders trust. MTTR drops because they no longer start incidents by reverse engineering intent from tangled exclusions. They start with code and evidence. Takeaway: every exclusion rewrites your threat model. Treat conditional access as compiled policy, not a canvas for quick edits, and erosion stops being possible by accident. The cost of conditional chaos, measurable impact. If your governance is real, it has a dashboard. If it doesn't, you have a story, not a system. Concrete example. A leadership review asks, are we safer this quarter? And the team shows tickets closed, trainings delivered, and a pile of screenshots. None of those answer the question that matters. Did effective authorization converge on intent? Without hard signals, you negotiate confidence. With signals, you measure it. Consequence? In conditional chaos, the curves move the wrong way silently. Consent velocity rises because just admin consented scales faster than review. Blocked permissions stay at 0, not because you're good, but because nothing blocks anything. Standing privilege roles accumulate under temporary pressure. PM activations spike because every routine task requires elevation. MTTR stretches when an incident lands because responders can't trace effective permission without breaking production. You don't have drift, you have compounded ambiguity. Spec Kit fix. Tie every number to a decision you no longer argue about. You stop sampling posture and start compiling it into KPIs that behave. Primary metric 1. App consent velocity. Count of new grants per month, normalized by active projects. In chaos, velocity drifts up, then hockey sticks when agents replicate patterns. Under enforcement, it flattens. Why? Scope allow lists and consent workflows tied to spec IDs make bad requests fail in CI. Fewer bad requests reach humans. Same throughput, less sprawl. Identity architect. Velocity down is not less shipping. It's less dead landing. Primary metric 2, blocked permissions. In a healthy system, this number spikes early. That's the gate doing work. Each block is a non-allow listed scope that died before aging into debt. Over time, as templates encode norms, spikes flatten to a steady low hum. If blocked permissions are near zero and you're shipping, you're not exceptional. You're breakless. Fast contrast example. Team A implements the gates. Blocked permissions jump from to 37 in week 1, then settle at 4 to 6 per sprint. Consent velocity drops 40% and stays flat. Team B, prompts better. Blocked permissions hold at ear. Consent velocity climbs 15% quarter over quarter. Same tools, different physics. Primary metric 3, standing privileged roles. Count of non-PIM assignments above the threshold. In chaos, this creeps up because temporary becomes permanent by inertia. Under constitutional RBAC and prohibited combinations, it trends to 0. The side effect is noticeable. PM activation frequency also trends down. Least privileged design removes elevation for routine work. Incidents require fewer escalations. Activations become short, rare, and auditable. Security engineer. We didn't make PM harder, we made it unnecessary more often. Primary metric 4, audit posture. Findings closed without compensating controls is the only line that matters. In chaos, you borrow story points from audit season to rewrite evidence. Findings roll over renamed rather than resolved. With Spec Kit, you close them with artifacts. Allow lists, invariants, RBAC models, gates, and workflows referenced by spec IDs. The dashboard reads like a compiler log, not a diary. Primary metric 5, effective coverage for conditional access. Not policy exists, not report only enabled. Calculate the percentage of identities always enforced by each control with no user or group exclusions per persona. In chaos, you don't know this number, it's a guess. Under invariants, it's a query. You watch it climb because user-based exclusions are mechanically impossible, and workload identities never pretend to be humans. Platform engineer. We replaced seems enforced with a percentage and a diff. Primary metric 6, MTTR for access incidents. In chaos, responders begin with questions. What can this principle do? Where can it go? What breaks if we revoke? Answers arrive by spelunking, not by code. Under enforcement, you trace effective permissions in minutes because scopes, roles, and policies map to spec IDs and owners. Quarantine is precise. Rollbacks are surgical. MTTR shrinks and its variance narrows. Now connect each curve to a gate so causality is explicit. Consent velocity flattens because CI refuses non-allow listed scopes and deploy refuses orphaned grants. Blocked permissions spike early because rules are live. They flatten as templates normalize inputs. Standing roles decline because prohibited combinations and PIM requirements are encoded, not requested. PIM activations fall because least privileged designs replace elevation with app roles and narrow APIs. Effective coverage climbs because user exclusions can't merge. Workload identity patterns replace human bypasses. MTTR drops because ambiguity is engineered out. The graph is legible by construction. A quick micro-story to make the numbers breathe. A mid-sized tenant began with 312 active grants, 29 standing privileged roles, and an unknown effective coverage. After 8 weeks of constitutional rollout, 198 active grants, all with owners and spec IDs, standing roles down to 3 with decommission dates, effective coverage for MFA, and approved client apps above 96% for humans, workload identity adoption at 81% of pipelines, blocked permissions stabilized at 5 to 7 per sprint, MTTR for access incidents cut from 11 hours median to 3 hours with tighter spread. No heroics, gates plus templates. Governance lead. The best argument is a graph moving the right way. One more fast contrast. 0 blocks is a great headline if you're breaking a bicycle. It's a horror movie if you're breaking a truck. Don't celebrate silence. Celebrate shaped noise that declines for the right reasons. Takeaway. What you don't measure, you negotiate. Turn intent into numbers that move in one direction. Downward for debt, upward for coverage, and conditional chaos turns into conditional evidence. Spec Kit. Constitutional governance for AI-driven development. If governance isn't executable, it's ornamental. Constitutional governance turns your identity posture into law the system compiles, not guidance the system may ignore. Concrete example. Before Spec Kit, a team documented least privilege in a wiki, used certificates in an onboarding doc, and no user exclusions in a slide. 5 documents, 0 enforcement. After Spec Kit, 1 constitution declares non-negotiables, every feature carries a spec ID, pipelines compile changes against those rules, and approvals reference the same ID. One artifact chain, one source of authority. Consequence, decisions stop living in meetings and start living in code. Ambiguity drops because the only successful path is the compliant one. Here's the structure you need to make that real. First, the Constitution. This is the short list of laws you will not debate per sprint. They're the invariants, not opinions. Examples that matter. Identity policy classes with universals, no user or group-based exclusions, approved client apps required for interactive access, device compliance only for human personas, legacy auth blocked tenant-wide. Break glass is a sealed pattern with high assurance signals and alerts. Authorization guardrails, scope allow lists by app class, delegated permissions prohibited for daemons, PIM mandatory above threshold, prohibited role combinations codified in the G application administrator plus cloud application administrator. Authentication. Primitives. Certificate-based client credentials for workloads. Client secrets prohibited in production. Redirect hygiene prohibits wildcards and local host beyond sanctioned dev paths. Tenant invariants, naming patterns, owner assignment required, audience rules, external partner allow lists with reviews. This is the law of the land. It's short, explicit, and machine checkable. Second, specifications. Every capability that touches identity ships with a spec that answers what must be true for this feature. It includes the allowed graph operations and scopes by class, the auth model, the persona mapping, the conditional access posture, and the evidence queries that will prove coverage. It carries an immutable spec ID, think spec onboard 001, that threads through planning, tasks, CI failures, approvals, and telemetry. If a change affects identity, it cites the spec ID. If a gate blocks a change, it points to that ID. Third, planning. This is where AI can help safely. The model proposes SDK versions, libraries, flows, and contract shapes. The plan compiles those proposals against dependency allow lists and tenant invariants. If it selects a preview graph SDK, the plan fails and points to the approved 5x range. If it reaches for an auth helper that enables device code for daemons, the plan fails and offers the certificate path. You still get speed, you just stop importing capability drift disguised as convenience. Fourth, tasks. Break the plan into atomic, verifiable tasks linked to the spec ID with success criteria a machine can check. Scopes equal the allow list for class onboarding. Reader. Workload identity uses certificate. Policy includes approved client apps, no user exclusions. Redirects are explicit. This is how you replace vibes with checks. Humans stop sampling. Gates prove conformance, task by task. Fifth, implementation, where gates do the teaching. CI and deploy gates act as negative proofs. Permission gate, request directory, read write. All for a reader class. CI fails closed, prints the expected scopes, and links to spec onboard 001. A youth gate. Attempt to create a client secret in prod. Deploy fails with the certificate template and key vault binding. Policy gate. Submit a user-based exclusion to an always enforced policy. Policy compiler denies with the violated clause. Dependency gate. Pull a preview package into production. Manifest scanner rejects and points to the allow list. Tenant gate. Register an app without an identity owner. Deploy refuses and opens the owner assignment task. Each failure returns the violated law and the shortest compliant path. Developers learn faster than any review could teach because the feedback is immediate, precise, and unambiguous. Governance lead. We didn't invent ceremony. We bound authority to artifacts the system can verify. Now the approval layer, because not all changes are equal. Change control becomes your legislature, not a help desk queue. Tier 1, auto approvals for low-risk, spec-conformant changes captured by gates. Tier 2, human approvals for new scopes that sit inside the class allow list or redirect additions that meet invariants. Tier 3, dual approvals for RBAC changes, new always enforced policies, or partner integrations. Tier 4, constitutional amendments, exceptions to invariants with sunset dates, compensating controls, and telemetry hooks. These are rare, explicit, and expensive on purpose. Every request references the spec ID, shows a diff before-after, and includes CI evidence that it compiled everywhere else. Approvers click once because the system did the analysis. Exceptions aren't stealth edits. They are visible, time-boxed laws with built-in expiry. Platform engineer. We traded arguments for diffs. Make the payoff tangible. Before, 5 documents, everyone aligned emotionally, nobody aligned operationally. Permissions landed through portal clicks. Conditional access eroded through quick fixes. Audit meant storytelling. After, one constitution, many specs. Pipelines compiled intent. Gates blocked entropy at source. Audits closed with artifacts. KPIs moved predictably. Identity. Architect. If it isn't executable, it isn't governance. Consequence of adopting this, your AI becomes safe leverage. The model still generates variants, scaffolds plans, and drafts tasks. It just can't ship shapes that violate the Constitution. Sampling becomes fuel, not fire. One fast contrast to end the chapter. Without a constitution, least privilege is a principle debated in stand-ups. With one, it's a property your system proves at build and deploy. Without spec IDs, provenance is memory. With them, every permission, policy, and role traces to intent. Without gates, you discover problems in audit. With gates, you discover them in minutes. Takeaway: constitutional governance turns intent into law the system compiles. If you can't point to the rule, the spec ID, the gate, and the evidence, you're not governing, you're hoping. Governance Artifact 1, Identity Policies. If your policy isn't executable, it's ornamental. Identity policies are not guidance, they are the compiler switches for personas, human, workload, emergency that make decisions deterministic at runtime. Concrete example: a team proposes a human corporate access policy with require MFA, require compliant or hybrid joint device, approved client app requirement, and disabled legacy protocols. It sounds right, but here's how it compiles under Spec Kit. Scope: all human users. Explicit exclusions are forbidden. Conditions: device compliance required, sign-in risk high, require phish-resistant MFA, client app must be brokered. Controls: session restrictions for unmanaged fallback are disallowed for this class. Evidence: queries that compute effective coverage percentage across the human persona. Consequence: the same JSON that used to be a best intention object becomes a tested artifact. If a contributor attempts to add a user-based exclusion for VIP group, the policy gate fails. Identity policy invariant: no user group exclusions for human, always enforce. If they try to flip the policy to report only to monitor first, CI denies it for the always enforce class. Failure is instant, precise, and points to the spec ID. Drift dies at the source. Now a fast contrast before we go deeper. Previously, a help desk runbook suggested temporarily disable approved app requirement for a user troubleshooting broker issues. It shipped quietly and lingered for months. Under Spec Kit, the attempt fails at pull request with the violated clause, and the remediation: use the workload identity pattern for automation or fix the brokered client on the endpoint. No silent bypasses. Takeaway: if it isn't executable, it isn't governance. Here's the policy kit that makes this durable. Persona classes encoded in the Constitution: human. Always enforce, require phish-resistant MFA, require compliant or hybrid joint device, approved client app required, legacy auth blocked. No user group exclusions permitted, report only disallowed. Workload, identity, certificate-based client credentials, app-enforced restrictions replace device compliance, no delegated permissions, no MFA prompts, tagged so human controls never apply. Emergency. Break glass, time-boxed activation from a just-in-time workstation pool, high assurance signals, continuous monitoring. No persistence, alerts on creation, use, and expiry. Specification for each policy class. Scope definition as a deterministic selector, and G, directory filtering by engineered attributes, not free text dynamic groups that drift. Conditions mapped to personas, human device compliance versus workload tags. Controls defined by strength and forbiddances. Approved app requirement cannot be disabled for human classes. Prohibitions enumerated as failing tests: no user, group exclusions, no report only, no legacy protocols. Evidence queries, custo or graph calls that compute effective coverage by persona and produce a diff. Gates that compile policies, not read them. Lint rejects anti-patterns like all cloud apps minus list n or device compliance requirement targeted to a scope that includes service principles. Scope validator denies policies that reference dynamic groups with non-deterministic rules, emoji title-based membership. Requires engineered attributes or system-managed tags. Enforcement classifier prevents report only on always enforce classes. Drift reconcilers. Nightly jobs compare effective targets to spec and quarantine or open remediations for stale GUIDs, renamed groups, or orphaned conditions. Walk failure as feedback so developers learn immediately. A contributor submits a policy excluding contractors EU from MFA to ease onboarding. CI response: denied by human, always enforce no group user exclusions. Use staged rollout with increased auth strength and central onboarding pattern. See Spec HPOL 003. Another tries to target device compliance to a scope that accidentally includes service principles. Gate denies. Workloads cannot be evaluated by device claims. Move candidate identities to workload identity pattern. Minutes, not months. Identity architect. Device-based decisions are binary at runtime. Configs are not. Enforce the binary where decisions happen. Make exclusions feel dangerous with one more vivid path. A partner B2B integration asked for a location-based exclusion so their IPs bypass MFA. Months later, the partner's IP range changes. Your exclusion now covers a shared range used by coffee shop Wi-Fi. Under invariants, location-based bypasses for human are forbidden. The partner gets B2B direct connect with workload tags and conditional controls. No blanket bypasses, no surprises. Platform engineer. We replaced exception art with 3 patterns: Human, workload, emergency, everything fit. Metrics tie the loop. Effective coverage becomes a query, not a story. User group exclusions trend to 0 by mechanical impossibility. Approved client app coverage climbs because the policy both requires it and refuses edits that disable it. Legacy auth blocks reach full coverage because anything else can't merge. When blocked policy edits spike at first, it's enforcement doing work. When they flatten, it's norms encoded in templates. If 0 blocks, something's wrong. You have no breaks. Security engineer. Policy that compiles is the only policy that survives contact with urgency. Takeaway? Identity policies must be compiled artifacts with persona classes, prohibitions as tests, and evidence queries. If a change can't pass the compiler, it can't erode your posture. Governance Artifact 2, Dependency Allow Lists. The fastest way to import risk is through your dependencies. The agent doesn't pick libraries because they fit your standards. It picks what it has seen most often. Concrete example. A squad scaffolds an onboarding reader. The agent selects Microsoft Graph Latest, pulls an OAuth helper that supports client secrets by default, and includes a preview beta client because a blog post looked modern. Everything compiles. Tests pass. Hidden inside those choices, a secret-friendly code path you didn't intend, a moving API surface you can't pin, and transitive packages that silently enable device code in a daemon. That's not a bug. That's supply-side entropy. Consequence? Capability drift lands before a single permission request. Developers do the right thing, and the right thing still erodes posture because the toolchain carried the wrong shapes. 6 weeks later, you're remediating secrets in workloads, reconciling SDK breakage across pipelines, and explaining why a background service tried a human flow. Spec Kit fix. Default deny the supply chain and make the allow list the shortest path. Identity architect. Don't confuse works with permitted. The helper that compiles isn't the helper you want. Here's how the constitutional layer turns this into law. Constitution sets the stance. Default deny, explicit allow. Approved libraries and major versions only. Preview or experimental packages forbidden in production. Authentication primitives are part of dependency governance. Workloads must use certificate-capable libraries. Any package that supports secrets in production paths is banned. Specification narrows by app class. Line of business daemons get Microsoft, Graph 5.x, and Azure. Identity with X509 certificate credentials. Interactive internal tools use brokered MSL clients. Test-only projects may reference beta clients in isolated folders that never ship. Gates make it practical. Planning compiles agent proposals against the allow list. CI scans manifests and transitives. Deploy blocks non-conforming artifacts. The scanner doesn't just read top-level package. JSON or CS proj, it walks the tree, flags preview packages, and searches for banned symbols like secret client credential or device code invocations in daemon classes. Walk failure as feedback so learning is immediate. A dev adds Microsoft, graphed beta to test a new endpoint. CI fails. Preview packages prohibited in production projects. Use folder tests, beta, and build config beta only. See Spec Deps 004. Another pulls an OAuth helper that writes client secrets to disk. Gate blocks, banned symbol secret, write to file detected. Use Azure Identity X509 with template SCA225. A transitive dependency introduces device code flows into a service assembly. The linter denies device code API reference in non-interactive project. Switch to client certificate credential. Minutes, not months. Platform engineer. Transitives were how Entropy snuck in. The walker shut the door. Make the risk visceral with one more angle. A team pins to Microsoft. Graph latest minor. A month later, a change deprecates behavior your daemon relied on. The fix cascades across 4 repos. Under all our lists, you pin major, approve patch ranges, and test upgrades intentionally behind a plan. Throughput stays high, surprise stays low. Fast contrast. Before enforcement, 3 repos, same feature, 3 different auth stacks. 1 secret friendly, 1 device code, 1 correct. After enforcement, 3 repos converge on certificate credentials, approved graph 5.x, and identical retry telemetry behavior. You didn't lecture, the compiler did. Here's the concrete policy kit. Dependency allow list file per language, ecosystem, machine, readable, versioned, reviewed like code. It lists package names, approved major versions, permitted patch ranges, and classifies packages by persona, human, workload, test. It also defines banned symbols and patterns. Transitive policy. Any transitive not on the allow list is flagged. The rule provides 2 remediations. Replace the top-level package with an approved alternative or add an exclusion in the build that removes the transitive when feasible. The system prints the exact chain so developers don't spelunk. Preview quarantine. Preview packages live only in designated test folders with build configs that never ship. CI enforces folder scoping. Deploy treats preview artifacts as production blockers. AUth primitive enforcement in code, static analyzers for popular stacks verify that workloads instantiate client certificate, credential, or equivalent, not client, secret credential, or device code. Human apps must use brokered flows only. Any mismatch fails the build with the violated clause and links to the spec. Governance lead. If the right library isn't the shortest path, you already lost. Tie this to KPIs so you can see the slope bend. Blocked dependency violations spike early, then stabilize as templates bake approved imports. Secrets in code findings trend to 0 because secret-friendly helpers cannot compile. Incidents tied to SDK regressions drop because latest is not a policy. Delivery velocity increases because developers stop hunting auth examples. The template provides one path that passes first try. Failure as feedback one-liners teach the loop. Denied Microsoft graph.beta in production project. Move to tests push beta. Denied client secret credential in workload assembly. Use client certificate credential. Denied device code flow reference in non-interactive class. Switch to app credentials. Denied unapproved transitive com.contoso.auth helper. Replace top-level Contoso SDK with approved Contoso SDK Lite. Security engineer. Gate speed checklists. They don't trust vibes, they compile imports. Takeaway. Default deny your supply chain. Pin what's allowed, ban what's dangerous, and let gates do the teaching. Governance artifact 3. RBAC models and prohibited combinations. Roles aren't entitlements, they're contracts. If you don't constrain which powers can coexist, escalation isn't a scenario, it's a certainty. Concrete example. A well-meaning ops engineer gets application administrator to fix a consent glitch. Another day, they're granted cloud application administrator temporarily to unblock an app proxy. Each role alone is survivable. Together they can create, update, consent, and grant app permissions end-to-end. That's a full authority circuit, hidden in plain sight. Nothing rings, nothing breaks, until you need to explain how an internal tool suddenly gained tenant-wide access without passing through a board. Consequence, standing privileges stop being the immediate threat. The combinatorics of authority become the threat. 2 medium roles become 1 high-risk capability. A pipeline service principal with directory readers plus a custom role that can assign app roles is functionally an admin if nobody forbids the pair. Escalation isn't exotic, it's algebra. Identity. Architect. Most rollups aren't malicious. They're architectural. Pairs make powers you never meant to exist. Spec Kit fix encode separation of duties as code, not as a slide. Then make prohibited combinations fail closed. Start with the constitution, define the persona catalog, and the never together set. Examples that matter. Human personas, developer, platform operator, incident responder, identity administrator, auditor. Non-human personas, line of business daemon, automation agent, partner integration. Prohibited pairs, sample, application administrator plus cloud application administrator, privileged role administrator plus security administrator, directory writers of any kind plus consent grant authority, user administrator plus authentication administrator, any high-impact human role plus break glass privileges, any privileged role assigned to service principals. These aren't suggestions, they're constraints your policy engine can evaluate. Specification turns that law into per-persona contracts. Each spec lists permitted roles, PM eligibility, maximum activation duration, dual approvals where needed, and, critically, explicit prohibitions. A developer persona might get no Entra privileged roles ever. A platform operator uses narrowly scoped Azure roles, PM eligible, with 4-hour max and business justification. An incident responder gets time-boxed security reader and, when needed, PM elevated security administrator with dual approvals, never combined with privileged role administrator. Non-human identities get custom app-scoped roles, certificate authentication, owner assignment to the identity team, and 0 tenant-wide admin roles. Gates do the teaching. Request to assign application administrator to a developer to create an app registration faster. CI fails with denied by developer persona, no directory admin roles. Use app registration as code module with identity ownership. See Spec RBAC Dev 001. Proposal to grant cloud application administrator to an ops engineer who already holds application administrator for a prior ticket. The RBAC gate fails. Prohibited pair AA plus KA. Split duties. Root consent through identity. Attempt to give a pipeline service principal directory readers for exports. Gate denies. Standing directory roles are prohibited for non-humans. Use custom app role with read-only scope and certificate AUth. See Spec RBAC NL003. Failure as feedback reduces debate to diffs. The job prints the prohibited pair, the violated clause, and the shortest compliant path. Minutes, not meetings. Walk it as a timeline to show the payoff. Month before enforcement, 3 temporary grants stick. AA for a feature team, CAA for a platform engineer, and a one-off privileged role administrator to fix PM settings. The blast radius is one email away from end-to-end control. Month 2, someone creates a partner app that just needs consent. The AA plus CAA holder provides help. No malicious intent, just convenience with authority. Month 3, Audit asks who can create apps, grant consent, and assign roles. The answer is a shrug because combinations aren't tracked as combinations. They're lines in separate logs. Now the contrast under Spec Kit. Month prohibited pairs encoded. Any attempt to add CAA to a human already holding AA fails closed. The owner gets a remediation. Split duties. Either root through identity or remove AA first and timebox CAA via PIM for the specific change. Month 2. Partner app request lands as a Tier 3 change. The workflow compiles scope, consent path, and who can approve. No individual has the pair that could rubber stamp in a sprint. It's designed by friction, enough to stop the accidental circuit. Month 3. Audit doesn't ask who might have combinations. It runs a query, prohibited pair count, and evidence attached. Platform engineer. We cut off entire families of oops by making the compiler refuse them. Make non-human identities explicit because that's where drift hides. Service principals multiply, outlive owners, and quietly accumulate capability. The Constitution forbids tenant-wide admin roles for non-humans. The spec whitelists custom roles with narrow API-aligned actions. Gates verify. Any attempt to grant global administrator, application administrator, or a role above the custom set to a service principal fails with non-human principal cannot hold tenant-wide admin roles. Use app roles or narrowly scoped custom role. Now the human pressure point. Incident at 2 a.m. Can we just assign security administrator to the PIM admin to unblock investigations? Without code, that's a quick portal click. With code, the gate rejects. Prohibited pair, PRA plus SA. Use incident responder persona with PIM-gated SA and dual approvals. The escalator becomes a pattern, not a bypass. Change control provides the escape valve with friction. Tier 4 constitutional amendments can propose temporary exemptions, sunset date, compensating controls, telemetry, but they can't sneak in. The waiver itself is code. It expires on its own. Alerts fire if it lingers. Metrics tie the loop so you see movement, not intent. Standing privileged roles trend to 0 because non-PM assignments above threshold can't merge. Prohibited combinations detected stays at 0 or pages a responder when it flips. Average PM activation duration trends under the max because least privileged designs remove elevation from routine work. Escalation requests shift from Slack to structured approvals with evidence. Security engineer. We didn't make people perfect. We made dangerous shapes unspellable. One last failure as feedback burst to lock muscle memory. Denied. Assigning CAA to user U123 violates AA does CAA prohibition. Remove AA or root via identity. Denied. Assigning directory readers to SPHR export, non-human directory read via custom app role only. Denied PRA request for incident lead who also holds SA prohibited pair. Use incident responder persona. Takeaway. Treat roles as contracts and encode never together in code. If a combination can synthesize power you didn't intend, the operation shouldn't exist. Governance Artifact 4. Tenant Invariants. Laws of the tenant are not preferences. If a law can be bypassed by a pull request, it isn't a law. It's a suggestion the system will ignore under pressure. Concrete example. A team registers HR tool with no owner, a free text display name, localhost and wildcard redirects for testing, and a client secret set to expire in 2 years. The app works. A quarter later, nobody can find the owner to approve a change. The wildcard redirect migrates into a prod manifest through pipeline reuse. The secret appears in a script to make rotation easier. Nothing looked malicious. Everything was negotiable. Consequence, the directory becomes archaeologically interesting. Ownerless objects linger because deleting them feels risky. Redirects become attack surface by accident. Naming chaos kills your ability to query and classify at speed. Secrets proliferate behind good intentions. When an incident lands, responders begin with guesswork, not evidence. Spec Kit fix, define tenant invariants as constitutional law, compile them in CI and at deploy, and reconcile runtime drift on a schedule. Identity architect. Tenant invariants are your gravity. They keep everything falling the same direction. What belongs in law, not in law, naming and classification. App business unit purpose env with character limits and allowed sets. Display names mirror the pattern. No emojis, no test app, no ambiguity. Why? So you can select, quarantine, and retire with a query, not a scavenger hunt. Ownership. Every app registration has exactly one primary owner in the identity team, plus a service owner group. Ownerless objects are rejected. Why? Because who approves this is not a Slack thread, it's a property. Authentication primitives. Workloads authenticate with certificates pinned to approved CAs with rotation cadence. Client secrets are prohibited in production. Why? Because non-repudiation is a property, not a reminder. Redirect hygiene. No wildcards, no localhost outside sanctioned dev paths. Redirects must resolve to approved domains. Why? Because just for testing becomes now in prod when pipelines copy files. Audience and token posture. App audience and token lifetimes follow baseline. No personalized experiments in shipping code. Why? Because identity assurance is not per team. Consent posture encoded once. User consent disabled tenant-wide. Admin consent requires a workflow with spec IDs and app classes. Offline access allowed only for classes that prove need and rotation. Delegated perms prohibited for daemons. Why? Because capability deployment must have provenance. External boundaries. Partner allow lists, B2B and cross-tenant access rules are explicit and reviewed. Guest redemption requires strong identity proofing. Why? Because trusted partner IPs isn't a control, it's a myth. Platform engineer. We didn't get stricter, we made bad shapes impossible. Failure as feedback. How the gates teach instantly. Attempt to create app HR tool with no identity owner. CI fails. Owner required. Assign primary owner from identity. Attach service owner group. See Spec 10 own 001. Attempt to add redirect https://contosoapps.net. Plan fails. Wildcard prohibited. Enumerate explicit URIs. See Spec 10 redir 002. Attempt to set a client secret on a workload. Deploy blocks. Secrets prohibited for workloads. Generate X509 via template SCA 2025 and vault it. See Spec 10 IUth 003. Attempt to set audience or token lifetimes outside baseline. Gate denies with the violated clause and links to the constitutional section. Attempt to enable user consent. Refused. Tenant invariant. User consent disabled. Use admin consent workflow linked to a spec ID. Consequence. Developers don't memorize rules, they learn by compilation. The path of least resistance becomes the compliant path because the wrong shapes cannot land. Make this visceral with operational reconciliation. Scheduled jobs compare runtime state to invariants, owner, reconciliation, quarantine ownerless objects, notify identity and service owner group, auto-retire on timer expiry. Redirect scan. Flag redirects outside approved domains, open remediations automatically. Secret detection. Search for secrets on workload principles. Block usage. Trigger certificate onboarding. Name hygiene. Detect objects of pattern. Open rename tasks with proposed values. Security engineer. We stopped letting drift sneak in. The compiler refused it. Reconciliation erased leftovers. Human pressure moment, where invariants matter most. A rush demo needs a new redirect today. Without law, a wildcard lands temporarily. With law, the plan fails, the developer adds the exact URI, the demo still happens, the wildcard never exists. Fast contrast snapshot. Before 5 documents, 0 enforcement. Redirects and secrets just for dev drift into prod. Ownerless apps resist deletion. Audit is a month of spreadsheets. After, 1 constitution with machine checkable invariants. CI and deploy compile every shape. Reconciliation quarantines stragglers. Audit opens with a query and closes with evidence. Governance lead. If it isn't enforced where objects are born, you're doing archaeology. KPIs that prove invariants are working. Ownerless apps, trending to 0. Quarantine counts decline as hygiene stabilizes. Secrets in prod 0 by mechanical impossibility. Wildcard localhost redirects outside dev 0 by plan failure. Orphaned admin grants, trending down, all grants mapped to spec IDs and owners. Mean time to retirement for stale principles, measured in days, not quarters. Tie each number to a gate so causality is explicit. Owners at 0 because ownership is required in CI. Secrets at 0 because the deploy step prohibits them. Redirects clean because the plan refuses wildcards. Grants governed because workflows require spec IDs. Retirement fast because quarantine and timers exist. Takeaway. Tenant invariants aren't pros, they're laws the system enforces. And codenaming ownership redirects auth primitives, consent posture, and partner boundaries as code, compile them everywhere, and reconciliation will keep reality aligned with intent. Governance Artifact 5, testing gates. Gates are negative proofs, machines that refuse forbidden shapes so drift can't cross the boundary. If a violation can pass, you don't have a policy, you have a paragraph. Concrete example. A team submits a pull request that adds directory, read-write all to an onboarding reader. CI compiles the manifest against the class allow list and fails fast. Denied by onboarding. Reader. Use user. Read all. Group more read all or app role onboarding. Writer via spec onboard 001. The developer adjusts the request and reruns the job. Build goes green in minutes. Nobody schedules a meeting. Nobody writes a retrospective. The gate taught the right move once permanently. Consequence, failures arrive when change is cheapest. You stop discovering problems in audit and start discovering them in a branch. Cognitive load drops because violations are precise, actionable, and attached to the spec ID that owns the rule. Security engineer. Gates beat good intentions. They're fast, specific, and they don't argue. Spec Kit fix. Treat gates as a 4-stage compiler. Generation, build, deploy, reconcile. Same laws everywhere, no backdoors. Generation gates intercept the plan. The agent proposes dependencies and flows. A validator compiles the plan against allow lists and tenant invariants. Microsoft.graph bonked beta in a production project, rejected with the approved 5x range. OAuth helper that writes secrets, rejected with the X509 template. These gates prevent a bad day later by preventing a bad plan now. Build gates enforce shapes before merge. They run quickly, locally, and in CI. Permission gate compares requested scopes to the app class allow list, prints the expected set and a link to the spec. Dependency gate scans manifests and transitives, forbids previews in production, bans secret-friendly symbols and human flows in daemon assemblies. Policy gate lints conditional access. JSON blocks user group exclusions, all apps -n, and report only on always enforced policies requires engineered attribute scoping. RBAC gate evaluates persona contracts and prohibited pairs, refuses standing privileged roles above threshold and dangerous role combinations. Tenant gate verifies naming, owner assignment, redirect hygiene, audience and consent posture, fails ownerless objects and wildcards with direct remediation. Deploy gates validate effective state before apply. They call graph, PIM, and policy engines to compute what the tenant will look like with the change. Ownerless app. The deploy step refuses to create it and opens an owner assignment task. Policy would reduce effective coverage for human. Denied with the violated clause. Service principal asking for directory readers. Blocked. The job prints the approved custom app role and cert path. Reconcile gates run on a schedule and catch runtime drift. Orphaned grants, stale GUIDs, renamed groups, secrets on workloads, redirects outside approved domains, or coverage gaps. They quarantine, notify, and auto-retire with timers. This is your garbage collector for identity. Platform engineer. Same rules everywhere. If the wrong shape can't merge, it can't deploy. And if it sneaks in, reconcile and timers take it out. Failure as feedback make it visceral. Denied. Files, read, write, all not on tools, reader, allow list, use content, export, app role, spec, cont, 007. Denied, device code flow reference in non-interactive assembly, switch to client certificate credential. Denied, conditional access, user exclusion in human, always enforce. Use workload identity pattern. Denied, A plus CA pair for user U123, split duties, root consent via identity. Denied, wildcard redirect, https iapmasht.contosoapps.net. Enumerate explicit URIs. Identity, architect, gates don't shame, they root. Scalability rules so developers keep moving. Local first run the same validators as CI with a single command, no waiting for a remote pipeline to learn a rule. Parallelization, permission, dependency, policy, RBAC, and tenant checks run concurrently, green bars in seconds, not minutes. Caching and versioning. Allow lists and invariants are versioned. CI logs which version enforce the decision. Rollbacks are deterministic. Human ergonomics. Every failure message names the violated clause, the spec ID, and the shortest compliant path. No scavenger hunts. Governance lead. We didn't add gates to slow teams. We added them to remove bad paths. Fast contrast example. Before gates, an over-permissioned scope ships. The audit finds it 6 months later. The fix takes a quarter. After gates, the scope dies in CI. The developer ships in the same hour. One organization celebrated 0 blocks. They were breakless. After enabling gates, blocked permissions spiked for 2 sprints, then normalized. Velocity went up, variance went down. Tie the gates to KPIs you already track. Consent velocity flattens because CI refuses non-allow listed scopes and deploy refuses orphaned grants. Blocked permissions spike early, then settle as templates harden. Standing privileged roles trend to 0 because RBAC gates prohibit non-PIM and dangerous pairs. Effective coverage rises because policy gates can't merge exclusions. MTTR drops because reconcile keeps the graph legible and deploy gates prevent ambiguous state. Takeaway: gates are compilers for identity, generation, build, deploy, and reconcile that turn intent into deterministic outcomes. If a shape can't pass a gate, it can't create drift. Governance Artifact 6. Change control and approval workflows. Approvals are not ceremony, they're your legislature. If gates are the courts that interpret law, change control is how law is made, amended, and repealed deliberately with evidence, not vibes. Concrete example: a team wants to add mail. Read-write to an internal analytics tool to export reports faster Before Spec Kit, this landed as a chat thread and a portal click. After Spec Kit, it lands as a tiered request with a spec ID, a diff, and proofs. The form shows current scopes, proposed scopes, class allow list comparison, the CI result that failed the raw scope and passed the app role alternative, and the runtime impact graph. Approvers don't debate taste. They review a delta with receipts. Consequence, urgency stops bypassing intent. Approvals become a small number of predictable pathways, each tied to risk and compile time evidence. Most requests self-approve because they already conformed. The few that don't get daylight, context, and accountability. Security engineer. If your approval needs a meeting, your artifact was incomplete. Here's the tiering that turns escalations into system behavior. Tier 1, low risk, auto-approve, changes that match allow lists, personas, and invariants. Examples: adding a spec-conforming redirect, updating a certificate on a workload identity, requesting read-only scopes within an app class. Requirement: pass gates, attach spec ID, log evidence. Approver of record is automation, tier 2, medium risk, single approval, changes that expand within guardrails. Examples: adding a new read scope inside the class allow list, enabling a new brokered client app for human personas, onboarding a partner's approved read-only integration. Requirement: CI evidence, plan diffs, runtime coverage impact. Approver, identity team, tier 3, high risk, dual approval, authority changes with real blast radius. Examples: new conditional access policies in always enforced classes, RBAC assignments above threshold, partner right integrations. Requirement: spec ID, risk summary, rollback plan, CI and deploy gate proofs. Approvers, identity and security. Tier 4, critical, constitutional amendments, exceptions to invariants. Examples: temporary allowance of a preview SDK for a pilot, a time-boxed relaxation of a policy due to vendor breakage. Requirement: sunset date, compensating controls, monitoring hooks, owner, telemetry binding. Approver, CISO, or delegated board. The amendment is code and self-expires. Platform engineer. We traded opinion for oracles, diffs, and proofs. Failure as feedback, show how the legislature teaches. A contributor submits a tier 2 request to add files. Read-write all to a tool class with read-only allow list. The system pre-runs evidence. Denied, scope violates tools. Reader allow list. Alternative exists. App role content. Export via spec conte 07. CI passed for this path. The request converts itself into the correct change. No escalation, no committee. Another pushes a tier 3 request to add a user-based exclusion to meet a demo deadline. The policy compiler blocks. Human always enforce forbids user thus group exclusions. Use workload, identity pattern, attach spec-wide 0003 proof. The request is rejected with the only compliant route. Identity architect. A good approval flow never asks for trust. It asks for the diff. Ownership is explicit to prevent ghost decisions. The identity team owns scope, app registration posture, and tenant invariants. Security owns conditional access and RBAC posture. Platform owns rollout choreography and backout steps. Business owns necessity and timing. Every approval is signed by a persona, not a mailbox. Evidence is immutable and linked to the spec ID. Make emergency posture feel safe, not loose. Break glass is its own tier 4, just-in-time workstation, high assurance, dual approvers on call, time-boxed activation, automatic deprovision, and live alerts. After-action automation creates a root cause record. What non-emergency path failed and what constitutional change removes that failure mode? Governance lead. Escalation is a design decision, not a vibe. Tie metrics to decisions you stop negotiating. Median approval time by tier 1 seconds, tier 2 hours, tier 3 days, tier 4 rare and deliberate. If tier 2 drifts upward, your evidence bundle is missing standard proofs, fixed templates, not people. Rejection reasons by clause. Top causes print where to improve training and templates. Scope not on allow list, prohibited pair, policy invariant violation, missing owner, become bar charts, not surprises. Waiver count and age, small and time-bound. Auto expiry is a graph you watch. If waivers linger, amend the constitution or fix the platform. No zombie exceptions. Rollback rate, low and falling, because requests pre-compile. If rollbacks rise, your oracles are weak. Tighten gates, not change control. Fast contrast. Before, approvals were chats, screenshots, and force merges. After, approvals are diffs, evidence, and time-boxed law. Before, temporary lasted forever. After, waivers self-expire and page you if they don't. Takeaway: approvals aren't whole passes, they're your legislature. Bind every request to a spec ID, pre-run the proofs, tier the risk, and make exceptions code with sunsets. If an approval can't cite the law, the diff, and the evidence, it's not governance, it's negotiation. From spec to enforcement, the implementation story. The only requirement for success is refusing to ship anything the Constitution can't prove. If intent holds at every handoff, drift doesn't get a chance. Concrete example. A platform team inherits a sprawl of app registrations, broad graph scopes, and policy exclusions. They pick one leak, AI-generated onboarding readers asking for directory, read, write, bond all, and run the loop. The result isn't a meeting, it's a compiler. Here's the 5-step arc, walked once, then contrasted fast. Step 1, problem definition. Not a dashboard, a slope. They inventory the tenant, count active app registrations, tag owners, export OAuth grants, list conditional access policies with exclusions, and enumerate standing privileged roles. 2 KPIs set the baseline, consent velocity is rising, blocked permissions are 0, and standing privileged roles number 29. The heat source is clear, onboarding readers keep requesting write scopes and getting approved to keep testing moving. Identity architect. If you can't draw the curve you intend to bend, you are not ready to bend it. Step 2, spec creation. They draft the constitution entries that matter now, not tomorrow. Scope allow lists by app class. Delegated permissions prohibited for daemons. Client secrets banned in prod. No user-based policy exclusions. Prohibited role pairs encoded. Then they author Spec Onboard 001, a feature spec for onboarding readers. It names the only permitted scopes, user, read all and group read all, and the write path, an internal API app role onboarding, writer behind server-side validation. It maps personas, auth model, and evidence queries for coverage. The spec gets an immutable ID. Everything downstream cites it. Platform engineer. We replaced guidance with a contract. Step 3, planning. They let the agent propose the stack. Microsoft. Graph 5.x Azure identity with certificates and retry telemetry defaults. The plan compiles against the dependency allow list and tenant invariants. A preview SDK rejected with the approved range. An OAuth helper that supports secrets rejected with the X509 template and key vault binding. The plan includes a quick start, sample calls to the internal API for writes, and a test matrix that hits success and failure paths. Security engineer. We didn't trust the plan because it was pretty. We trusted it because it compiled. Step 4, tasks. The plan breaks into atomic verifiable steps linked to Spec Onboard 001, T001. Manifest requests only user. Read all and group read all. T002 workload identity uses client certificate credential. T03 policy coverage proves approved client app requirement hits human persona. No user exclusions permitted. TW4 dependency scanner passes. No preview packages. No banned symbols. T005 API app role onboarding. Writer available. Integration tests call it not raw graph writes. Each task defines the check a gate will run. Humans stop sampling, machines prove. Governance lead. We moved review from taste to tests. Step 5, enforcement. Gates do the teaching at generation, build, deploy, and reconcile. Generation. The plan validator refuses preview graph or secret-friendly helpers and prints the approved alternatives. Build, permission gate, denies directory, read-write, all for the reader class and prints the expected set with a link to Spec Onboard 001. Dependency gate rejects device code references in daemon assemblies. Policy linter blocks any user-based exclusion and all cloud apps -n. Deploy. Runtime validator refuses to create ownerless apps, blocks secrets on workloads, and denies policies that would reduce effective coverage. The job prints the violated clause and the fix. Reconcile. Nightly jobs quarantine ownerless objects, flag unexpected redirects, and alert on coverage regression. Failure as feedback turns minutes into muscle memory. A developer bumps graph to latest and the walker flags a preview transitive. The message names the chain and the fix. Another tries to skip the internal API and request files. Read write bot all. CI denies and prints use onboarding writer via Spec Onboard 001. They swap one line and ship. Fast contrast. Before enforcement, the reader ships with write scopes. Audit catches it 6 months later. The team burns a quarter untangling grants. After enforcement, the scope dies in CI. The compliant path deploys in the same hour. No grant ever existed to clean up. Now the timeline payoff. Week 1. The team runs an inventory, assigns owners and tags every grant with a spec ID or unknown. Blocked permissions leap from 0 to 37 as gates go live. Consent velocity dips. Week 2. Onboarding readers across 3 repos refactor to the API app role pattern. Secrets vanish from workloads because deploy forbids them. Week 3. Conditional access exclusions for service principals shrink as pipelines adopt the workload identity pattern and human coverage ticks up. Week 4. Dashboards stabilize. Blocked permissions normalize to 5 to 7 per sprint. Standing privileged roles drop to 3. All time boxed. Effective coverage for human exceeds 96%. MTTR for access incidents falls from 11 hours to 3 with narrower variance. Identity architect. Direction is the result, not the speech. Make the pressure moment explicit. A product manager asks for a Friday demo. Can we just grant right for speed? The gates answer not people. The denial points to the API role, the sample call, and spec onboard 001. The demo happens, the bypass doesn't. Tie the loop to a second fast example to cement the pattern. A partner integration requests directory, read all insights. Read write all to simplify sync. Under the Constitution, partner integrations get a reviewed set. Offline loss access is rare and rotated. Writes go through app roles. The plan compiles or the request fails. No debates, no favors. Takeaway: implementation is not a meeting, it's a compiler. Problem: spec, plan, tasks, gates. If a shape can't pass a generation, build, deploy, and reconcile, it can't create drift. The accountability shift, measuring governance outcomes. Direction is proven by curves, not ceremonies. If intent holds, the numbers move predictably and no one argues. Concrete example. A quarterly review asks, are we safer? Before you showed trainings and tickets. After constitutional rollout, you show 6 lines that explain themselves. Consent velocity trending down and flat, normalized by active projects. Blocked permissions spiking early, then stabilizing low as templates harden. Standing privileged roles decaying towards 0, remaining assignments, PIM, eligible, time-boxed. PM activation frequency dropping as least privileged designs remove routine elevation. Effective conditional access coverage climbing by persona, computed from queries, no user group exclusions. MTTR for access incidents shrinking with tighter variants because responders trace effective permissions in minutes. Consequence: each metric maps to a decision you stop negotiating. Velocity down means gates filtered requests before humans. Blocks up then steady means enforcement teaches faster than reviews. Standing roles down means prohibited combinations and PM rules remove the easy buttons. Coverage up means exclusions can't merge. MTTR down means ambiguity is engineered out. Fast contrast. Team A treats governance as code. Blocked permissions rise to 41 in sprint 1, settle at 5.7, consent flattens, MTTR drops from 10.8 to 3.1 hours. Team B prompts better. Blocked permissions stay near 0, consent climbs 15% QoQ, incidents linger. Identity architect. 0 blocks isn't excellence, it's 0 breaks. Spec Kit fix. Bind every KPI to a gate and a spec ID. Consent velocity flattens because CI denies non-allow listed scopes. Deploy rejects orphaned grants. Blocks stabilize as enforcement-ready templates encode norms. Standing roles fall because RBAC compiler refuses non-PIM and dangerous pairs. Coverage rises because user exclusions are mechanically impossible. MTTR contracts because scopes, roles, and policies are traceable to spec IDs and owners. Takeaway: what you don't measure, you negotiate. Compile intent into numbers that move one way. Down for debt, up for coverage, and confidence stops being a meeting. Taking back architectural intent. AI didn't break your identity system. Unenforced intent did. Compile intent, constitution specs, gates, and drift can't land. CTA. If this changed how you think about Entra, subscribe and share with the person who owns identity in your org. Then watch the enforcement templates deep dive. We'll hand you the modules and tests. Stop delegating decisions to convenience. Start compiling intent.